All right, so now I got it all aligned. So the domain we said was all real numbers, but x cannot equal plus or minus 2. Before we go on to find vertical asymptotes, let's take a pause for the cause and let us come up with the factored form of our function. I can factor an x out of the top, correct? That leaves me with x squared minus 9. I can't factor anything out of the bottom. However, those can both be written as x minus 3, x plus 3, and x minus 2, x plus 2. Anything factor out? That's good. Our problem just got one step shorter, right? Nothing factors out, therefore there's no holes. Okay? All right. So now let's go back to my vertical asymptotes. What are said vertical asymptotes? Let's flippity floppity flop them. Whoa. Why did it go away? Onto our graph. Yes. Okay. Horizontal asymptotes. Why none? Top's bigger. Yep. How much is the top bigger by? Ooh, is that something that I need to... Don't worry, Jacob. I think you're going to do just fine. Okay. X-intercept, or excuse me, y-intercept, the int. F of 0 is going to be 0 minus 0 on top, all over 0 minus 4 on the bottom. That's 0 over negative 4, which is 0. So that gives me a int of the origin. Okay. X-intercept is next. What do I do for my x-intercept? Since we already factored it, I'm going to use the factored form to set that one equal to 0. So that's going to tell me that x equals 0, that x minus 3 equals 0, and that x plus 3 equals 0. So that is going to tell me that I have 3 x-intercepts. The origin, which I already knew because that was my y-intercept, positive 3, 0, and negative 3, 0. Step 5. No holes. Said that before. Step 6 now. Can I do synthetic division? No. So I have to go long division. X is the first thing that I'm going to multiply by. That's going to give me x cubed minus 4x. Change my signs. goes away, nothing, negative 5x, drop it like it's hot. See that? Is there any way that I can make x squared look like negative 5x? No. So then that becomes my remainder. So I've done my long division. What do I do now? What do I do now? Drop the remainder. Because when I multiply this in, this line right here is x times x squared minus 4. Right? Which is x cubed minus 4x. Right? So I got to line them up. Then I change my signs. So my slant asymptote is y equals x. So let's put that on there. Now we need to find some other points, right? So over here I have there. So let us go with 1, 2, 3, 4, 5. Let's go with 6. It's going to be kind of huge. So my function once again was x cubed minus 9x over x squared minus 4. So 6 cubed is what, 216? It is. Minus 54 is 162. 36 minus 4 is 32. What's 162 divided by 32? A little bit more than 5? Yeah, 5.06. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And oops, I got to go up just a little bit. 3, 4, 5, 6. 1, 2, 3, 4, 5. Just a little bit more than 5. Okay? Do I have enough information out there in zone 3? Yeah, I would agree that it comes in along here, comes down. Yeah. Okay. Let's go with zone 1, or zone 2, I should say. We'll go with positive 1 and negative 1. If I put positive 1 into my function, I get 1 minus 9, which is negative 8, over 1 minus 4, which is negative 3. So that then would give me positive 8/3, which is 2 2/3. If I put negative 1 in there, that gives me negative 1 plus 9 is positive 8 over negative 3, which would be negative 2 2/3. So that one looks like it comes in here. It goes out like that. in the middle, you can. Only vertical asymptotes. Can't cross a vertical. And then over, whoa. And then over here, let's go with -6. So that's going to be -216 plus 54 is going to be -162 all over +32. So that's going to be a little bit less than -5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right in there. That should be enough. So then we've got, through here. Like so. Yes? Wonderful. Good stuff. Great stuff for not a lot of money. Festival foods.
Oh, this one's good stuff. Let's do this one.
Domain. What's the domain? Plus or minus 2. Huh? So all real numbers, but x cannot equal plus or minus 2. All right? Let's pause for the cause, and let's factor. So the top is x minus 1 times x plus 1 times x plus 2. The bottom is x minus 2 times x plus 2. What happens? X plus 2's cancel each other out, so that leaves me with x minus 1 times x plus 1 all over x minus 2, or x squared minus 1 over x minus 2. Wink, wink, nudge, nudge, sign of things to come. Okay? So, what are the vertical asymptotes then of my function? X equals 2. Horizontal asymptotes of my function. But it's one bigger, right? So that means I'm going to have a slant. Y-intercept. Zero comma 1/2. X-intercept. Holes. Slant asymptote. Yeah? Everybody with me so far? Do I need to show any of those steps? Slant asymptote one? Okay. So the slant asymptote, I'm actually going to take this right up here, and I'm going to do the division in it, which is why I re-multiplied it out up there. Okay? So that tells me that I'm going to take x minus 2, set that equal to 0, so that's going to be x equals 2. So I'm going to divide 2 into 1, 0, negative 1. Drop it like it's hot, multiply, atom, multiply, atom. Okay? And then I forget about my 3, and that leaves me with x plus 2. Okay? Alright? Now let's throw all that stuff on there. So, we've got a vertical asymptote at x equals 2. We've got a slant asymptote at y equals x plus 2. I've got a y-intercept at 0, 1/2. I've got an x-intercept at 1, 0 and negative 1, 0. I've got a hole in my bucket, dear Liza, at negative 2, negative 3/4. I think that's enough on this side. Yeah. 4 points on that side. Pretty good. Okay. Over on this side, let's go with 3. If I put 3 into my function, I get 8. 1, 2, 3, 4, 5, 6, 7, and 8. If I put in 4, I get 15 halves, which is 7 1/2. And if I put in 6, I get 35/4, which is 8 3/4. Yeah, it pulled up a little bit. I see that. There it goes. That I like better. Good observation. And there you go. And that's all she wrote. Good times. So, this weekend, you have a review packet. Right? This one will be due Wednesday because your test is on Wednesday. Okay? Put it in the good stack, wrong stack. Okay? Alright? 20? Yeah, 20. Okay? No formative tomorrow.